Okay, so let's continue. We had already started our second session. We had looked at presenting data using visual aids. We had also looked at tables and graphs, what they are. We also looked at cross-tabulation, and that was the last aspect that we looked at. So we now want to continue. We need to understand why is it important for us to use graphical methods when we are presenting data in our reports. Like I mentioned earlier on, graphs are easy on the eye. Like people like to see pictures. It's easier to look at the data through a picture, such as a graph. People also like to see colors or different types of graphs. It gives them a break from reading typed work. When they see a graph, they also easily look at the data. So it's very important to present our data using graphs and table to make it easier for the person who is reading our reports. So we've got different types of graphs. There are so many, but today we're going to look at the histogram. We'll also look at the bar charts. There are different types of bar charts that we shall be developing together on Excel. Also, there are pie charts, also trend line. I mentioned earlier on what trend line, so we shall be developing it using Excel. Then there's also scatter plots and linear regression line. So the type of chart depends on the data available, and also it depends on your objectives. So hopefully after this session, it will be easier for you to choose the graphs or tables that you may want to include whenever you write up some reports or you present data. So this is what a bar chart or bar graph looks like. Okay, we shall do it together, but just for you to see what it looks like. For example, this one is showing the number of customers on the y-axis, and on the x-axis you are seeing the months. So January there are 200 customers who maybe approached the shop or who bought from a specific person. February 300, March 500, and so on. So that is a bar chart. Okay, you notice that there are gaps between each bar. So these bar charts are graphs that interpret the relationship between two or more variables using the rectangular bars that you've just seen. And they can be drawn either vertically or horizontally. So this one that we have seen is vertical one, and is the most common one, but you can do it horizontally. It's all up to you as the presenter or researcher. So the bar diagram makes it easy to compare sets of data between different groups at a glance. Okay, for example, let's go back to it, this one. You can actually see at a glance without necessarily reading through how many customers were there in January and how many customers were there in May or April. So it's quite easy to make a comparison to see the month with most customers and the month with least customers using a bar chart. Okay. And they represent categories on one axis and discrete value in the other. So the goal is to show the relationship between those two axes, and they can also show big changes in data over time. Okay, like you may see a big change in the number of customers at a given month. Okay, so the axis, the horizontal and vertical axis, the horizontal one, okay, that's the former, represent the independent variables, while the latter one is the dependent variable. Okay, so the vertical one is dependent while the horizontal one is independent. So horizontal, so these are the variables here, the dependent and the independent ones. Okay. So like I said, horizontal, it gives us the months. So the months are dependent, okay? So the months are independent, whilst the vertical one, the the number of customers are dependent on the months. Okay. So how do we use bar graphs to present data? Like I said, they can be grouped into different types depending on how the bars are placed, and they are used to display data that has been collected and organized in categories. Like you have seen on our example, that the data was in categories, as in months versus the number of customers. So an example of categories is cars of different colors, which we discussed earlier on. So it's another way of categorizing data that you can put in a bar graph. The length of each bar shows the value that the bar represents. Okay. And this, now what is important for us as we construct this bar graph is to look at the interval, okay, on the graph. You can see here that we've got an interval of 100 along the vertical axis here, the number of customers. We are moving from 1, 2, 3, 4, 5, okay. So if the largest frequency, say, was only 15, then you can, sorry for that. If the largest frequency was only 15, then it is difficult to use the intervals of 100, because it means that your largest bar graph will be here and you will have nothing up to 600. So if it is 15, it means you may want to have intervals of maybe 1 up to 15 or 2, 4, 6, 8. But in this case, we are dealing with large numbers of customers, hence we have intervals of 1, 2, 3. So it all depends on your data. Okay, so we can't use interval of 1 on this type of data to say we've got 1, 2, 3 up to 600, because the graph would not fit here. Okay, it would be very large and difficult to read. Is it making any sense?
So,
okay, thank you.
right.
Okay, then besides the simple bar graph, we also have what is called the stacked bar graph. We shall do this also in Excel. It's also called composite bar graph. It divides an aggregate into total parts. So you can also use this kind of graph when you are presenting data. For example, you can see here that you've got utilities in green, rent in blue, food in red, and gasoline dark blue or navy blue. So it's showing perhaps the expenses by month of a specific person. Okay, maybe this is the first month, second, third, and fourth. Okay, so you can actually put this in stacked format. And these parts are typically identified by utilizing different colors for each section. And the stacked bars require a legend or specific labeling to identify what the various parts of the bar are showing. So do not forget to add this legend, because if you just present this chart without this legend, it will not make sense to anyone. So it's very important. Then the grouped bar charts, okay. These are also called clustered bar charts. They represent discrete values or for more than one item that share the same category. For example, you are looking at a specific quarter, maybe, and then you are looking at different values in a given quarter. For example, assume this is quarter 1, then you find that for maybe different countries, you've got country A, country B, different values, then quarter 2, country A, country B, and so on. So we shall also be doing this during our Excel exercises. So a bar graph could display the number of individuals. It could be male and female with a certain trait for specific age. Okay. So the aggregate number of instances could be combined into one bar. It all depends on how you want to present your data. Alternatively, the instances could remain segregated by gender, one bar for all male instances and the other bar for all female instances would be placed side by side for each age group. So you may say that for people who are, maybe you can put a specific age group here if you want, maybe 20-year-olds, then you've got male, female, 25-year-olds, male, female, depends. Or if you are studying children, then 1-year-old, male, female, and so on. So this is a good bar chart, which you can also use to present your data. Okay, are there any questions on the grouped bar chart? Okay, then we move on to the histogram. What is a histogram? It is a graphical representation that organizes a group of data points into user-specific ranges. It is similar in appearance to bar graph, but the histogram condenses a data series into an easily interpreted visual by taking many data points and grouping them into logical ranges or bins. So it is the most commonly used graph to show frequency distributions. Okay, so many people use the histogram. And it looks very much like a bar chart, but there are important differences between them. So this helpful data collection and analysis tool is considered one of the 7 basic quality tools. So this is an example of a histogram. We are looking maybe at the average daily commute or the number of people who travel daily from one point to one specific point that we have an interest in to another specific point that we have an interest in. So you can see that actually it's minutes, not the number of people, the time that it takes for a specific person or specific people to move from one point to another. So you can see that 14 minutes, there's no one who takes 14 minutes. 16 minutes, we've got maybe one person. Then between, let's say, it's 18 to 20 minutes, we've got 2 people and so on, up to 30 to 32, we've got 1 person. So you see the difference between a histogram and a bar chart is that the histogram now, it condenses, there are no spaces, unlike in the case of a bar chart, there are no spaces in between. Okay, so that is the histogram that we want. Then we also have a pie chart. It is also known as a circle chart that divides the secular statistical graphic into sectors or slices in order to illustrate the numerical problems. So each sector denotes a proportionate part of the whole. Okay, and obviously the total value should be 100%. So we use the pie chart to find out the composition of something. And if you want to find out the composition, it's best to use the pie chart. And in most cases, the pie charts can be used to replace some other graphs like the bar chart, line plots, histogram, etc. So what I'm saying here is with your data, you can actually choose between, sometimes it's possible to choose between bar chart, pie chart, and also line plots. It all depends, and also maybe histograms. It all depends on how you want to present your data and how visible you want it, how you want to show it in your report. Okay. So this is an example of a pie chart. We are looking at favorite color. You see the different sections, blue, red, and so on. Okay, someone may just choose to label, put the labels here, or they may choose to put it as a legend here. It all works. So that's a pie chart that we can also use to present our data. Then there's what is called a line chart with a trend line. Okay, so you see the broken line now is the trend line. It shows the overall direction of our data, whilst this dark blue, this bold line is the line chart. So it's showing us for 2015, perhaps it was, oh, sorry for that. 2015, we had 50 observations and so on until we get to 2020. So it's another way of presenting our data. We want to see the number of employees over time. So you can actually see here the line chart is direction, and also the trend line, it shows the overall direction, showing that the number of employees was going down from 2015 to 2020. So that's a line chart with a broken line here, the trend line. Then we also can present data using what is called linear regression. So what is linear regression? It describes the relationship between variables by fitting a line to the observed data. So we want to look at the relationship between different variables. And when we are looking at linear regression, those models, they use a straight line. But when it is not linear, it doesn't use a straight line. But in this case, let's just concentrate on linear regression. So it allows a researcher to estimate how a dependent variable changes if the independent variable change. Okay, so you can actually estimate how productivity changes as salary changes. So we use what is called simple linear regression to estimate the relationship between the two quantitative variables. And we can use simple linear regression when we want to know, one, the first thing that we are going to illustrate as we go to Excel is to see how strong the relationship is between the two variables. Okay, for example, income and working hours, and also the value of the dependent variable at a certain value of the independent variable. For example, the independent variable here is income. The dependent variable is perhaps working hours. So you want to see how working hours change at a certain level of income. If we increase income for the employees, will they still want to work 8 hours a day, or they may want to work less hours? So we use linear regression to estimate that so that we can come up with a decision on the way forward. Okay. So this is how the chart will come up like when you do the linear regression. So it has got two issues here. There's this regression line in red, which is showing the relationship between two variables. Okay, for perhaps income and number, maybe income here and number of working hours if you want. As more hours are added, or maybe as income is added, people want to work more hours. Then this is called a scatter plot. The dots that you are seeing, the blue dots, are called scatter plots. They also help. We can even use that scatter plot without the regression line. You shall understand further when we illustrate how to come up with a scatter plot. But this is another way that we can use to present our data. Okay. Then the trend line is amongst the most important tools used by technical analysts. Okay. It helps technical analysts to determine the current direction. Like I've already shown you the trend line, remember? And it can be used with graphs. For example, if a company A, let's assume we've got company A here, and it is trading at $35, maybe US dollars, and moves to $40 in 2 days and $45 in 3 days. The analyst has 3 points to plot on a chart starting at 35. So the analyst will plot 35, 40, then 45. I'll show you just how they plot it. Then moving to 40, then 45. Okay. Starting at 35, then moving to 40, then 45. But if the analyst draws a line between all 3 price points, they have the upward trend. And the trend line is a positive slope. It is therefore telling the analyst to buy in the direction of the trend. But if company A's price goes from 35 to 25, the trend line is a negative slope, and the analyst should sell in the direction of the trend. So you have these slopes from 35, 40, and 45 for each day of trading. Day 1, $35, day 2, 40, day 3, 45. Or the second case scenario, day 1, 35, day 2, 25. I didn't put data labels here. But anyway, so these trend lines can help us to make decisions on what is likely to happen. Maybe day 4, a person can actually predict what is likely to happen on day 4. Or this could be years, year 1, year 2, year 3. Then when you present your report with such a trend line, a decision maker or even yourself as the decision maker can predict what's going to happen in year 4, and you can make a decision. But if you've got this scenario, you can actually see that it's going down. Year 1, year 2, or day 1, day 2. So you can predict that the next year, or the next day, this trend is going to follow. So you can actually make an appropriate decision for the for any specific scenario. In this case, it's about people who are trading. Okay, so the trend line is very important to help people make a decision. It can come this way, or it can be made using this format that I've shown you earlier, that from a line chart, we can then come up with a trend line. I'll show you how it will be done.